In this video, I'm going to talk to you about solving quadratic equations by completing the square. Before we get started with solving quadratic equations by completing the square, though, I want to remind you about how the square root method works. Let's say that you had a quadratic equation that looked like x plus 2 quantity squared equals 16. Now from here, we can take the square root of both sides, which gives us x plus 2 equals plus or minus 4. And then we can subtract 2 from both sides. So x is negative 2 plus or minus 4, which breaks out into two possible answers, negative 2 plus 4 or negative 2 minus 4. So x is either 2 or negative 6, and those are the two solutions to that quadratic equation. Now the goal of completing the square is to take something that doesn't quite look like this yet and turn it into a perfect square. If we take a look at this x plus 2 squared equals 16, notice that we could FOIL out x plus 2 squared, and we would get x squared plus 2x plus 2x plus 4. So x squared plus 4x plus 4 equals 16. Now our goal in completing the square is going to be to identify this magic number that we can add to something like x squared plus 4x to turn it into a perfect square, so that we can go back and use the square root method. Now that we know what the overall goal is, let's go ahead and take a look at another example. This time, we're going to start with x squared plus 6x minus 7 equals 0. Now, the first thing we need to do is get the x squared and the 6x on one side of the equation by themselves, so that we can figure out the magic number and add that to both sides to complete the square. So that means I'll be adding 7 to both sides. So x squared plus 6x equals 7. Now we need to find that magic number that we can add to both sides. A good trick here is that that magic number, that's what I call it anyways, the magic number, will always be b divided by 2 and then squared. So it's always the coefficient on x divided by 2 and then squared. So for our situation, the magic number is going to be 6 divided by 2 and then squared, which is 3 squared, which is 9. So that's the number that we're going to add to both sides of this equation. And that gives me x squared plus 6x plus 9 equals, what is that, 16. So at this point, whatever's on the left should be a perfect square if we've picked our magic number correctly. So let's go ahead and factor the left-hand side. We're looking for factors of 9 that add up to 6, and sure enough, those two factors are 3 and 3. And as a hint, that number there is always going to be the same as b over 2. These came from the same place, so it's not a coincidence that these two are the same number. You can count on those two to always be the same. Now that I have this factored into x plus 3 times x plus 3 equals 16, I can rewrite it as x plus 3 squared equals 16. And now I can apply the square root method to solve this equation. I can take the square root of both sides, which gives me x plus 3 equals plus or minus 4. Don't forget that plus or minus. That's where you get your two solutions from. Then I can subtract 3 from both sides to give me x equals negative 3 plus or minus 4, and that gives me my two solutions. It's negative 3 plus 4 and negative 3 minus 4. So x is 1 or negative 7. And those are the two solutions to that equation. Now let's look at an example where the lead coefficient is not 1, because this is going to give us one more step that we need to do. So say that we have something like 2x squared plus 16x minus 10 equals 0. If you're solving a quadratic equation by completing the square and the lead coefficient is not 1, the very first thing that you should do is divide by that lead coefficient to get it out of the way. So we're going to divide by 2. So I'll divide all my terms by 2, which leaves me with x squared plus 8x minus 5 equals 0. Now I chose numbers that would divide by 2 nicely. It's possible that you'll get an equation where you'll have a decimal here as one of these two numbers, and that's okay. It's still just a number, and you can still use the method of completing the square. Now that I have an equation that looks more like the one I looked at last time, where the lead coefficient is 1, I'll go through those same steps again. I'm going to get the x squared and the 8x on one side by themselves by adding 5 to both sides. And then I'm going to find my magic number and add that to both sides to complete the square. Remember that the magic number is the coefficient of x divided by 2 and then squared. So 8 divided by 2 and then squared is 4 squared, which is 16. So I'll go ahead and add that 16 to both sides of the equation. Now I have x squared plus 8x plus 16 equals 21. This over here should be a perfect square now if I've done my job correctly. I always like to double check that and factor it to make sure. I'm looking for factors of 16 that add up to 8, and sure enough, 4 and 4 multiply to be 16 but add to be 8. So I've got x plus 4 squared equals 21. And now I can solve using the square root method. I'll take the square root of both sides, which leaves me with x plus 4 equals plus or minus the square root of 21. Notice that the square root of 21 can't be simplified anymore. Now to finish solving, I just subtract the 4 from both sides, and x equals negative 4 plus or minus the square root of 21. And it's perfectly fine to leave your answers like that. Notice though that this is two different answers. This is negative 4 plus the square root of 21 and negative 4 minus the square root of 21. If you're working your homework with an online program like WebAssign, you'll probably have to enter those as two separate answers for the program to recognize it. And so now we've done two examples of solving quadratic equations by completing the square. And before the end of this video, I want to give you a couple of reasons to care about completing the square. The first is that later on in this class, when we start putting quadratic functions into standard form, you're going to be using this same method. And the second one is that this method of completing the square is actually where the quadratic formula comes from. So because we can complete the square, we can derive the quadratic formula, and then we can use it, which is very handy.